On 222 notes day 2. Before we begin these examples, make sure we keep these in mind. If you have a less than or greater than or equal to sign, you're going to use a solid line. If you have a less than or greater than sign, you're going to use a dotted line. And then we also know where we're going to shade our solutions based on our inequality symbol as well. So we're going to shade above our line if it's greater than or equal to symbol. And then we're also going to shade below if it's a less than or equal to symbol. One says solve the system graphically. We're first going to take a look at y is less than or equal to x plus 2. Based on our previous notes that we just took, we should realize that the first thing we should graph is our y-intercept, which is a positive 2. Is my direction to my next point. So our slope here is 1 over 1. Because it's a positive 1 over a positive 1, we have two options. We can go up and to the right one. Up 1 to the right one, up 1 to the right one. Or we could have gone down 1 to the left one, down 1 to the left one. Because this is a less than or equal to sign, I know I'm going to use a solid line. Also, because this is a less than or equal to sign, I know I'm going to shade below my line to represent my solutions. Okay, let's talk about y is greater than or equal to 2x minus 10. Y-intercept, which is at negative 10. And then my slope is my directions to my next point, which tells me this is a positive 2 over a positive 1, which means I'm going to go up 2 to the right one, up 2 to the right one, and so forth. Because this is a greater than or equal to sign, I'm going to use a solid line. Sign, I'm going to shade above. Our solution is where my green and orange is intersecting. So where these two shadings are intersecting right now, this is my solution. But we also have constraints here. X must be less than or equal to 0, and y must be greater than or equal to 0. So we need to shade that part of our solution that we have right now to represent these constraints as well. So any x value that's less than or equal to 0 and y value that's greater than or equal to 0 would put us right here in this corner. For example, if I chose a point from that shaded region in purple, let's say I chose negative 1, 1. Well, negative 1 is my x and 1 is my y. Negative 1 is definitely less than or equal to 0, and a positive 1 is greater than or equal to 0. So this would satisfy my constraints as well. So what this region shaded in purple right here is going to be our solution for this system of inequalities. An artist makes oil paintings and watercolor paintings. The artist takes 8 hours to paint an oil painting. He takes 6 hours to paint a watercolor painting. He has set aside a maximum of 24 hours per week to paint his paintings. It takes 2 hours to frame and put the final touches on oil paintings, and he takes 3 hours to frame and put the final touches on his watercolor paintings. He has set aside a maximum of 12 hours per week for framing and the final touches. Write a system of inequalities that represents the time the artist has to complete his paintings. Graph the solution. So here we're talking about the number of oil paintings and the number of watercolor paintings. Because these are two different types of paintings here used within this word problem, we're going to have to establish our variables and they will be different. So x is going to be the number of oil paintings, and y will be the number of watercolor paintings. The artist takes 8 hours for an oil painting. Well, we just said x is the number of oil paintings, so we're going to have that be represented by 8x. It's 6 hours for watercolor paintings. So we're going to have 8x plus 6y, and then he has a maximum of 24 hours. If you have a maximum of 24 hours to complete a task, you can complete that in less than that amount of time or equal to that, but you don't want to go over that time. So we're going to use less than or equal to 24. So that's our first inequality. Our next inequality is going to be represented by what's shaded in purple. It takes 2 hours to frame the final touches, to frame and put the final touches on the oil painting. Well, X represents the number of oil paintings, and if it takes 2 hours to frame and put the final touches on each, we're going to represent that as 2X. It takes 3 hours to frame and put the final touches on the watercolor paintings. We're going to represent that as 3Y. And then he has set aside a maximum of 12 hours. So again, we're going to use a less than or equal to symbol here, because he can complete that in less than that time or equal to that, but he doesn't want to go over that. All right, and then we have our constraints for this problem. We do have to establish these. We're going to have x is greater than or equal to 0 because we cannot have a negative amount of oil paintings. So we need to establish that x is going to be greater than or equal to 0. That means we also need to establish a constraint for our watercolor paintings. So y is greater than or equal to 0. So here's our 4 inequalities. All right, and I've divided them up using a line in between each just because we're going to have to get these first two into slope-intercept form. So that means we're going to have to solve each of these at the beginning for y. Let's start with our first one. 8x plus 6y is less than or equal to 24. Now again, the reason we want to get these into slope-intercept form is because that's going to help us when we graph them in our next part of this example. The first thing you should do for 8x plus 6y is less than or equal to 24 is you're going to subtract 8x on both sides. So we're going to be left with 6y is less than or equal to 24 minus 8x. We cannot combine those. Those are not like terms, so we're just going to write them next to each other. 8x plus 24. Excuse me, negative 8x plus 24. We're going to divide both sides by 6. So we get y is less than or equal to negative 8 over 6. If we put that in our calculator, it's going to simplify that fraction to negative 4 over 3x. Then we also have to take 24 divided by 6. If we put that in our calculator, 24 divided by 6 is going to give us 4. So that's our first linear inequality put into slope-intercept form. Now our next one, we're going to have to do the same thing, meaning we're going to solve for y here. So the first thing we need to do is subtract 2x on both sides. We get 3y is less than or equal to negative 2x plus 12. Just like our previous example, how we divided by 6 on both sides by every term, we're going to do the same thing here, except we're going to divide by 3 on both sides by every term. So on the left side, we're left with y. We're going to bring down our less than or equal to sign. Negative 2 divided by 3 is going to stay as negative 2 over 3. And then bring your x variable down with that. And then if I take 12 divided by 3, that's going to give me a positive 4. So our inequalities that we're looking at here, our linear inequalities that we're looking at here, are what's circled in red. And then we're going to use these to represent our system of linear inequalities graphically in the next part. So we're going to graph each of these inequalities. So I'm going to highlight these in different colors so you can know which color goes with which inequality graphically. First one, y is less than or equal to negative 4/3 x plus 4. We're going to use our y-intercept to graph our first point at positive 4. Then we have negative 4/3. So you have two options from your y-intercept. You could go down 4 to the right 3, and do that one more time as well. Or from your y-intercept, you could have gone up 4 to the left 3. Because this is a less than or equal to sign, we're going to use a solid line here. And because it's less than or equal to, we're also going to shade below my line to represent our solutions. Our next linear inequality, y is less than or equal to negative 2/3 x plus 4. First point you're going to graph is positive 4. And then I do have a negative slope again, so I'm going to go down 2 to the right 3 this time. Down 2 to the right 3, and so forth. You could have also went up 2 to the left 3 from our y-intercept. So right there I just went up 2 to the left 3, and I'm going to do that one more time. And because this is a less than or equal to sign, I'm going to use a solid line. And this also tells me I'm going to shade below my line because it is a less than or equal to sign. Now I'm really focused on my solution here where the orange and the green intersect here. But we also have to remember we have constraints. My x is greater than or equal to 0 and my y is greater than or equal to 0. So we're going to highlight where the green and orange intersect, but also where my x values are greater than or equal to 0 and my y values are greater than or equal to 0. So it looks like we're just going to be dealing with what's in our first quadrant here. For example, if I pick the point 1, 1, that's in that region of solutions. This is my x, this is my y, and within that ordered pair, my x value is greater than or equal to 0, and my y value is greater than or equal to 0. If I scroll down here, I'm going to show you a zoomed in version of quadrant 1 here to give you a better understanding of where our solution is, and it would just be right in this region here. All right, so technically we're just using the first quadrant of the graph where these two shadings intersect, which is what's highlighted in purple. And this should give you a better understanding of our solution here.